works sends it into a loop, and by the time anyone notices, it burns $15,000 of your runway. Or even worse, a user gets tricked into a leaking sensitive data straight onto the internet. Here's the thing: we build software, we get an error tracking, rate limiting, firewalls. We build an AI, we had a credit card and hope for the best. Hi, we are quantum syndicates. We built Obsidian to fix that. It's a governance-based AI and cost audit layer that sets between the AI and the LLM calls. It enforces budget in the real time, blocks anything that violates complications before it ever reaches the model, and logs every single decision so nothing is left in the black box. Let me show you what it actually looks like. Obsidian is the full-stack AI governance and the audit platform. It's in between the application and LLM calls, and it does three things: enforces budget in real time, blocks queries that violate complication policies, and logs single decision onto the full edit traits. So as you can see, this is my home page where it's written the total number of queries we have written today, which is 12% more from yesterday. And here are all the things which it enforces and gives us this particular Obsidian websites and which clarifies the doubts. Now let's move on to the dashboard. So as we have used two engines, Cascadeflow for policy enforcement and routing, and Hindsight for systematic recall. Let's go to the lab. This is my dashboard area. This is the command center. The budget remains against the session caps, the total spent in every query latencies, the percentage of queries that can never be seen, and the policy that stops before it. This is the budget status. It isn't cosmetic underneath the cascade flags accumulated to the cost and persistent runs. It is a budget exceeded error that fires the budget when the request stops before it costs you anything. Now, as you can see, this is the Harriet cost curve. It plots per query the cost against the cumulative spend and accelerates the pattern immediately. This is the screen where it pulls to know within the 5 seconds the response is given here and the total amount of money spent is given here. And this is my dashboard. As you can see here in the audit section, I have received all the details and all the queries in which time which has been sent in. Now let's move on to the live query. So how the live query actually works. Here's what happens: that when you submit a query first, it classifies it into the category, like whether the category is audit status, refund, sensitive data, or it is a general fact. Then it goes to the pre-filled complications, logic-based API detection. So sometimes it is security and the number is caught with the key-based and due to the it works in the key-based break detection. Because of this, not paying much cost of LLM for the request that was never going to be allowed anyways. This query creates the Cascadeflow and checks the budget in the room. If there is the model-based routing going on there, it runs the Groq for interface and log. Every step: classification, complication, budget check, model choice, cost, latency, becomes an one audit event. So now as you can see here, if I write here whatever written policy and I just send it, it will give me the query here, and it will give me the response or the particular how the query works or how the result should be occurred here. Now we will be moving to the audit traits. So every one of those decisions that lands here, this is the audit trait: the timestamp, the category, the model used, cost, latency, and the final action taken. This isn't just a log for human; it is a backbone that the rest of the platform runs on. It is a trust scoring insight. It gives us the acceleration detection and reads the same event again and again. Like this is a paper trail that gives us all the details about the audits and which we have already given and which already is sitting there. As you can see, the timestamp, the date, whether it is allowed or not, the cost generated per that number, and all the things. Now let's move on to the auto remediation and insights. So Obsidian doesn't just watches it; it also reacts. Even like if you pass and give it the 10 events, it runs an acceleration pattern detection. If it notices any category quietly drifting towards the expensive model, it like auto remediation clicks and it just switches the router to the cheaper model automatically, and all that things works accordingly to that. Like if you take an example, if you trigger 10 queries at once on the camera or like in the Firebase, what will happen there? The Obsidian just flags that and drifts and it reroutes a cheaper level. In the cheaper model, it just switches to that. And if sensitive data is used, it blocks that particular data and it is not passed and it is not shown here. The main work of the insight is that it also taps the Hindsight semantic memory to surface the routing and the recommendation based on what has actually worked in historical and not just in the static routes. Now let's move on to the analytics page. So like what does analytics page do? It just zoomed out and it just categorizes by the cost and the model distribution what has occurred here. Like the actual spent against the baseline calculation from the expensive model query to a single expensive query which is very heavy. That numbers tells you what remediation is actually saving you. See, this is my analytics part and it shows my the cost category, the model distribution what has occurred, the latency distribution around 50 milliseconds and all, relative speed, what is the speed of actual query which is working here. So now move on to the trust phase. This is a very important phase. So this is one of what people ask about the most. The trust score, whether it is composite to 0 to 100 numbers, and the formula is fully transparent. 40% is through compilation. This shows that the event policy is passed through. 30% is cost efficiency, how the agency's cost and the average cost, the cheaper from the cheaper to the higher level. And the rest 30% recalls the accuracy, like how the testing of the Hindsight by asking what has been driven in the past and what is the history. It recalls all the details here. Like what does it do? It picks the agent and logs the custom ID and it computes the spot. Like I have computed the score and it has been given all the score, how it is working and all. Yeah. So like 100 with nothing is vandalized. Okay. So 50 recalls score of Hindsight is turned off. The point is trust. Trust stops being wiped and becomes a number which actually puts on the board deck. Now let's move on to the platform. So what does it do? That None of this is the data is shared. Every agent gets its own budget, its loop, its event loop. It has its own Cascadeflow and the run context is isolated. Like under the hood, what does this do? The agent AI and the Hindsight, it keeps the separate memory back, like in the baggage, it keeps that, so that if we run 5 agents together with different job models, five with 5 different budget and 5 different trust scores, none of them can spend from it, and it just matches that from the another agent register. So as you can see here, this is my platform, and it has given me all what I have worked till now. Now, in the Obsidian platform, let's come into this part, the setting, session, and health. This is the makeup of the system section of the dashboard. They are designed to give the administration deep control over how the application runs and tracks the uses. So here, what exactly session does? The session budgets and tracks the control. This session page is used to manage the active budget cycle of the AI agent. So what does it do is that since the Cascadeflow tracks how much money we have spent over time, this session lets you see that ongoing state going there. As you can see, 80 queries has been passed, and from that 8 queries has been blocked here. So what does it do? It monitors and it maxes out the agencies to the budget during testing time, and it pages and resets, and clear gives the simulation when we restart our page. So now let's move on to the health, which is the system diagnosis. This page is used mainly for the diagnosis monitoring. So what does it do? Like it checks the uptime and the connection latency of the code dependency which we have used. Like here you have used the Groq API. It monitors the Cascadeflow, the routing, the Hindsight semantics which we have used in the container. And why does this like mainly matters the health? Why does it matter? It matters because it's a query phase of the latency spikes. This is the first place if we see the Groq is down, or like the own backend engine is healthy or not. So as you can see here, the infrastructure has been drawn here, the client, the Obsidian gateway, and the Groq engine and the Hindsight database is given here, and all the detail of the real-time database is given here. It is same according to the time, it gives the real-time data. So now let's come to the most important part of this, which is setting. It is a global configuration. This page is mainly used to manage the system worldwide preference. What does it do is that it allows the user to update global configuration, such as it is used to manage their own API keys directly from the UI. It is used to toggle between the dark and the light mode themes according to the environment. And why does the setting mostly matters? It matters because it prevents you from the consistently adding the env files in every time you need to switch accounts and as per the global preference. So it prevents that, and it gives you the proper security. As you can see, if this is blocked here, it has been blocked. If any heavy query is used, so we will just on it because it is very harmful if any and it is very dangerous if any heavy query is used, because it blocks and the sensitive data and keeps it aside. The budget cost and all is given here as per GCD. We can just control it from here. And this is the model and the routing here. All the strategy model, fallback models, latency, and all are given here. The default model which we have used is Olama 3.37b versatile, and the category refund, it is allowed. Refund is allowed. General facts is allowed, but if any sensitive data is given here, it is blocked. And the integration of the API is also given here. And here is the danger zone, as you can see. So coming back to the dashboard, the budget enforcement that actually stops the query before it costs you. Complication checks that before it runs pre-filled. A complete audit trails behind every score on the dashboard. Auto remediation that saves money without even touching the sensitive data policy. And the trust score that you can actually see in the marathon. That's Obsidian. It's live right now. The link is in the description. If you want to try it yourself, you can try it. And if you're running an AI agent in production without anything like watching them, like it's genuinely worth before it costs you anything. So ending this presentation with the note that Obsidian turns an AI from a risky, opaque black box into a governed, measurable, and cost-aware system. Thank you.